So memory management basically, as with the storage of data on a hard disk, processes carried out by the CPU may also become fragmented. To overcome this problem, memory management will determine which processes should be in main memory and where they should be stored. This is called optimization. In other words, it will be determined that how memory is allocated when a number of processes or programs are competing with each other when a new process starts up. When a new process starts up, it is allocated memory. When it is completed, the OS deallocates memory space. So we will now consider the methods by which memory management allocates memory to the processes or programs or their data. So basically, the system that we are going to discuss today is paging. In paging, the memory is split into partition or blocks of fixed size. The partitions are not necessarily contiguous. The physical memory and the logical memory are divided up into the same fixed size memory blocks. Now what basically happens, let's say we have got three programs. Program A, program B, and program C. They all are basically stored in a disk. Storage. So these stored, this is hard disk drive. These stored programs are logically divided into different blocks or partitions of fixed size. We are not concerned over here that what is basically the size of each block, but all we are concerned is that these software, which let's call them ZAK, are installed over the hard disk and logically ये divide हुआ है. Physically divide नहीं हुआ, cut नहीं किया, logically divide हुआ है. So every single program is basically divided into number of instructions. So every block of this program would have certain number of instructions. So this is basically the physical memory. And on the other hand, we have got main memory. That main memory is also split up so that these pages from the physical memory are loaded into it. All right. Physical memory blocks are known as frames and fixed size logical memory blocks are known as pages. So these in main memory are called frames and over here they are called pages. All right. So let me revise. Physical memory blocks are known as frames and fixed logical memory blocks are known as pages. A program is allocated a number of pages that is usually just larger than what it actually needs. So if the program Z requires to be loaded, what will basically happen is that every single page of Z1, Z2, Z3 and Z4 will be allocated, let's say, how many pages are there in Z? There are 4 pages, but they will be allocated few more frames in the main memory. All right, so this memory, main memory is called physical, and this program installed over the hard disk is called logical. So a program is allocated a number of pages that is usually just larger than what it actually needs in the main memory frames. When a process is executed, process pages from the logical memory are loaded into frames in the physical memory. So let us call this logical memory, and this is called physical memory. All right. When a process is executed, process pages from the logical memory are loaded into the physical memory. A page table is used. A page table is something like this. Let us say this is frame. Frame number 1, number 2, number 3, number 4, number 5, number 6, number 7. This is job 1, which is loaded in frame 1, Z1, and then this might be A2, this might be Z3, this might be K1, and so on and so forth. So this is job pages, and these are the frames. So this is basically called what? Page table. System maintains this table, and this table maintains that which page of which job is loaded to what frame of the main memory or physical memory. All right. A page table is used. It uses page numbers as the index. Each process has its own separate page table that maps logical addresses to the physical addresses. The page table will show page number, all right. Sometimes it shows that page frame address. Sometimes there are flags attached, so more information can also be added to it. And sometimes the time of entry as well. So for the sake of simplicity, we just keep it to pages, and these pages are related to what page frame. So always please remember that it's not just these two, there might be the time of the entry and any flags. Flags, what are flags? We will discuss later. The time of entry is important when considering page replacement algorithm, when this page will be replaced by the other. Some of the page table status flags, let us discuss those, are, let's say, S flag. S means page size default value is less. Let's leave it. We don't need to be to discuss it in detail. Just leave it. Okay. So this diagram shows that how basically uh, only pages are loaded to the frames. Now there are advantages of it. There are basically advantages over the older systems. Let me tell you, in this is for comparative studies. This what we are going to discuss now is something that we don't need to have as far as our syllabus is concerned. It's just simple thing. In earlier system, there was a memory management system. Earlier system means जब हमारे पास DOS होता था, disk operating system, when multitasking was possible but with much difficulty. So let's say in the main memory, we have this main memory. Let's say there are jobs. Let's say A job, it is loaded in here. And then there is another job B, which is loaded here. And then there is a job C, which is loaded here. And then it is free memory. And then there is job D. Let's suppose that after some time, after some execution, this job A is now out of the memory. So this particular area where the job A was loaded and being executed, it is now finished. And this area of the memory is now being reported as free. So these free areas in the memory are called memory holes. So these are memory holes. Now what you need to understand is one thing, that programs are kept loading and deloading by the operating system. As and when they are required by the user, they are loaded, and when they are not, or they are user has asked them to be closed, they are closed. So this loading and deloading actually leaves a lot of memory holes in the memory. Number one. Number two, programs are basically not divided into parts, rather they are just loaded as a whole. This is an older management system, older memory management system. They were just loaded as a whole and offloaded when they are not required. So that loading and deloading creates so many memory holes. So we cannot break a program into pieces. Whenever it will be loaded as a whole. Now, what basically happens, let's say there is a new job E that needs to be loaded. Now this job E requires this memory as a whole and this memory as well. And we cannot split the job E. So what we would have to do, we will try to have this free space at one location. All right. So the first thing that you need to understand is basically variable partitioning. And second thing that is now required is compaction. Now, what is compaction? Compaction means we need to move programs from one memory area to another memory area for the reason that these programs are, when they are moved, all the free space will be at one location in the memory, and that collected free space after the movement of the program then can be used to load new programs. As the new program, which is E, requires as much memory as these two memory holes or these two free areas, we cannot split a program. Whenever the program in older system used to be loaded, it requires the whole memory at one place. So we have to move B and C either up or down towards the free holes so that all of the free memory could be found at one location. Now the thing is that when we move the program, it's not just like a move, just like moving the whole physical thing towards one side. Rather, a program is a collection of number of instructions. So we have to copy each instruction to a new location. So if we are moving program B above, we will take first instruction from this location and we will move it to the first location of this free area, and this way we will keep moving, keep moving, keep moving, keep moving, and then basically the whole B will be shifted to the free area above, and then we will start moving C upwards. So that is how the whole free space will now be available after C at one location, and then we will be able to basically have E loaded in the memory. So just realize what is happening. The most precious resource of the operating system is the processor time, and afterwards this main memory. If something is happening in the main memory like this compaction thing, the system go non-responsive. System for you becomes hanged. It is doing nothing. So whenever, this was a common problem, whenever a single hole is not able to accommodate the new program which requires to be loaded, compaction used to be done. So when compaction is happening, system is now silent for you and it is actually paying all its attention to the memory compaction. So this was a common thing that whenever we are loading a new program, computer go irresponsive, and we became used to with the delays when the program is being loaded. All right. So variable partitioning means every program is of a different size and they are given as much size required. And compaction means moving the programs in the memory, and those things, those two things were really hard to manage, especially because of the compaction. Now, related to this thing, get back to the paging memory. Now, what basically happens, only those pages which are required are loaded to the page frames in the main memory. Only those pages which are required are loaded to the page frame. So from the logical memory pages, only those pages which are required are loaded. Secondly, if the pages are loaded, they are not required to be loaded. It contain in adjacent areas. Rather, they can be loaded scatteredly in split order. So page frames come into action, and page frame then basically makes it possible to locate a page in the whole frame. So pages are assigned frames, and page table actually helps us to locate pages of the same program which might be scattered in different areas of the frames, and that is how it works. Only the pages which are required are loaded to the frames, not the whole program. So that gives us two benefits. Number one, programs amounting more collectively than the available memory can be loaded. What does it mean? Let's say you have got memory of 2 GB and the program, these three programs Z, A and K are actually taking up, let's say, 3 GB and they are still loaded. That is a benefit. We have got less memory but more size, bigger program than the memory are loaded. How? Because not the whole program is loaded, only the pages which are required are loaded. Number two, another benefit, compaction never happens. When compaction never happens, it means that you can load programs rapidly. You can load programs rapidly. So a page from the logical memory is taken and put in the frame right away wherever there is a page or frame available. Every program is basically assigned frames. All right. So that is how it works. Now, virtual memory. There is an operating system executive. What are operating system executives? Operating system executives are those programs which are basically the managers of operating system, and they are being called as and when required. So one of the manager or operating system executive is basically looking into these frames and any of the pages which are not being used for the longest available time are marked. All right, those are marked. Why? Because they are the idle frames for the most time. Now what happens, operating system allocates an area into the hard disk, and it is called virtual memory. This area is called virtual memory. Now what basically happens that sometimes the memory is now full, but few of the frames in the memory are not being used, so they are marked. Now you like to load page from the logical memory which is K1, and there is no space in the memory. Now what will happen, one of the marked frame page will be offloaded to the hard disk in designated area which is called virtual memory, and this Z1 then will be arriving in virtual memory, and this page is now available. The mark for idleness is now gone, and we will actually load what K1 into it. So that is how all of those pages which are idle for the most time are offloaded to the virtual memory, and then the new page that is required is loaded. That is the second advantage. It's a benefit of paging. Why? Even in the event when the physical memory is fully loaded, it has no more space. What basically happens? System creates virtual memory over the hard disk. What is virtual? Virtual is having a sense of being there when you are not there. Having a sense of something which is happening and exactly physically it is not happening. So you loaded a program, computer memory is full, but few of the pages from the memory which were idle are offloaded to virtual memory to have as much space available for the new program to be loaded. So your operating system does not ask you to try again because the memory is full. Have you ever had this message which says memory is full, please try again? It never happens because of this. So this is called virtual memory. So one of the problems encountered with memory management is a situation in which processes run out of RAM, main memory. If the amount of available RAM is exceeded due to multiple processes running, it is possible to corrupt the data used in some of the programs being run. This can be solved by separately mapping each program's memory space to RAM and utilizing hard disk if we need for the virtual memory. This is the basis behind the virtual memory, so you need to keep it in mind. Essentially, RAM is the physical memory, or virtual memory is actually RAM plus swap space on the hard disk. All right. Virtual memory is usually implemented using in-demand paging. In-demand paging is segmentation. In-demand paging is basically when new pages which are in demand needs to be loaded. So all those pages which are idle for the most time are offloaded to the virtual memory. That is how it works. To execute a program, pages are loaded into memory from hard disk whenever required, and when pages required to be loaded and there is no such space in the memory, in that case we will actually swap those pages with the virtual memory. Means we will move that virtual memory move those pages to the virtual memory and the new pages to the frame. All right. Sometimes what basically happens for the virtual memory, which is basically the main drawback or main issue that can arise. The main drawback when using hard disk is that as main memory files more, as main memory fills, more and more data or pages need to be swapped in and out of the virtual memory. All right, so it is now full. We need more pages. We are jumping in between the programs, and every program that we have jumped might have few pages in the virtual memory. They require to be loaded in the memory, and when they are required to be loaded in the memory, memory has got few idle pages, but we need to first send those idle pages to virtual memory and from virtual memory. So it is pages going back and forth between the physical main memory and the virtual memory in the event when the main memory is full. The phenomena attacks that is called thrashing, THRA, disk thrashing. Thrashing. So this is a high rate of hard disk read write, and what basically happens is the hard disk starts making noises. This is exactly with the mechanical hard disk, not with the SSDs, mostly with the hard disk. If more time is spent on moving pages in and out of the memory than doing any process, that starts giving us delays. So a process requires less time, and for that process to be available, to be executed, we have to actually move that process from the virtual memory to the frames, and for moving it back to the frames we have to offload few of the process from the frames to the virtual memory. That takes more time. Execution is in control of the microprocessor, which is quick. Lekin if it is being moved from hard disk to the RAM and from RAM to the hard disk, that is more time consuming. Such things, when it is happening, it is called thrashing. A point can be reached when the execution of a process comes to halt since the system is so busy paging in and out of the memory. This is known as thresh point. All right. So what is a thresh point? Thresh point is operating system is actually putting in more time swapping the pages between the main memory and the virtual memory rather than executing that point, executing that page. So execution requires less time, swapping requires more time, and you start feeling basically delays in execution. This is called thresh point. Due to the large number of head movements over the physical, mechanical hard disk, this can also lead to the premature failure of the hard disk drive. So thrashing is dangerous. Thrashing can be reduced by installing more RAM, all right, reducing the number of programs running at a time, or reducing the size of the swap file. Now, that is not in our control. So basically, this is what it is. Now let's solve a question which I had actually made for understanding of this topic. Let's have that question. This question is basically knife sort question. This is not a question which I just made this question so that you have a good idea of this particular topic. It is not covering the whole topic, but enough to make you ready for the exam. All right. So these are logical memory pages. These are physical memory pages. All right. These are logical and these are physical memory pages. And there are three programs, Z, A, and K, which we require to actually fill in this memory page. Now, what are frames? Frames are fixed size. Frames are fixed size physical memory blocks. And what are job pages? Fixed size logical memory blocks. Every program installed when loaded is divided into pages, and only pages required are loaded. What are memory pages or memory frames? Fixed size physical memory block. Every page loaded is accommodated into memory page frames. What type of memory management technique is being used here by the operating system? It is paging. All right. Then it says that explain what is meant by paging. So it is a form of memory management. It is a form of memory management technique which divides up physical memory and logical memories into fixed size memory blocks. It is mainly used by Windows operating system. Now, give two benefits of using paging. Benefit number one, programs amounting more than available memory size are or can be loaded. Reason, because only those pages that are required are loaded, not the whole program. Second benefit, we can still load programs when RAM is full. Reason, operating system makes use of virtual memory. All right. Okay. So that is how it works. So we will continue with a different topic next time. And thank you very much. If there are any questions, please do ask those in your respective groups or the video. Thank you.